Hello everyone, welcome to another video tutorial of ALE Lab. So in this tutorial I will be explaining the Lab 9 homework where we need to include like two AXI timers. So one is for the up counter having range from 63 to 255 and another is the down counter, 16-bit down counter. So from the block diagram, as you can see, like I have added two AXI timers, AXI timer 1, AXI timer 0, and both the interrupts from these AXI timers have been like using this concat block. I am passing the interrupt to this AXI interrupt controller, and then from this interrupt port I am passing it to the finally to the microBlaze processor. Now one error that most of you faced is like this microBlaze local memory has overflowed by some bytes. So this error we were getting in while building an SDK. So I was also getting the same error, so I've increased this size to like 128K and it got resolved. So this is one thing. And from the homework point of view, we need to add like two AXI timers, and rest of the things remains the same. And one thing to include, like in many of the reports I have seen, like some people are using still 4 bits, but since sir in the homework sir told like to display 16 for the AXI down counter, so this GPIO should be of 5 bits in order to display 16, and rest of the things remains the same. Okay, so this is pretty much the block diagram. Let me quickly go to the SDK code. So over here you can see like I have two reset values, one for the AXI timer 0 and another for the AXI timer 1. So this is the reset value of 63 and this is the reset value of 65535. And both I am using since this AXI timer in the block diagram, you can see these AXI timers generally have two counters, like internally they have two counters. So I will be using the timer counter 0 and timer counter 0 for both these AXI timer IP. That's why over here I have used the same timer counter 0 for both the AXI timers I have defined. And since the interrupts are generated from the two AXI timers, so there will be two interrupt handlers for both the AXI timers, so I have defined that. Next, everything more or less remains the same. These flags are not required. You can see like there is double definition, like twice definition of one for the AXI timer 0 and AXI timer 1 for the set handler. Then and I'm setting the options like for the AXI timer 1 for the down counter, this extra option like XTC down count option, and interrupt mode option is enabled like for both the timers. And I'm passing the reset value 0 and reset value 1, like different reset values for both the timers, and rest of the things pretty much remains the same. So let me go back to the this interrupt handler for the AXI timers. You can see like I have pretty much written the handler like this. So in many of the reports I have seen like they have done only AXI GPIO discrete write LED underscore GPIO 1,8. So whenever there is an interrupt, they're displaying 8, but they are not again resetting it back to 0. So it will be like whenever there is one time there is an interrupt, so it will be continuously displaying 8, 8, 8, 8, 8. So which shouldn't be the case actually, because whenever there is an interrupt generated, 8 should be displayed and again then it should go back to 0. Similarly for the interrupt handler 1, I am displaying 16 and then again it will go back to 0. And I have set like I will stop the timer whenever 4 interrupts being generated for the AXI timer 0 and as well as for the AXI timer 1. So you can see like I have set a condition like timer expired underscore 0 is greater than equal to 4. Then only I'm stopping the timer and setting options to 0. So this 0 will reset my timer finally, and I'm disabling the interrupt controller connected to the timer. Or that is for the timer 0 and for the timer 1. Okay, so this is pretty much about the SDK code. This is about the block diagram. Let me quickly show you the test bench. So in the test bench, nothing much. So over here, I have instantiated my DUT, that is lab9 underscore int underscore appart. So this name should be the same as this. And since the microBlaze is having active low reset, so first I am making reset is equal to 0 and then I'm putting reset equal to 1 for the things to work. and I'm setting a clock of like 10 nanoseconds, and over here I'm displaying the GPIO bits. Like whenever there is an interrupt occurs for the timers, either it will display 8 for the XI timer 0 and 16 for the XI timer 1. So to get a track of it in the TCL console, over here in the TCL console you can see. So after simulation, so I have used this dollar monitor. Okay, so let's run the simulation. Let's give it a time to get the. Okay, so it has come quickly. Okay, so quickly let me add the signals. Just add signals. Okay, so scope underscore under duty. So XI timer 0. I will add the interrupt first for the timer 0. Then its count out is inside this TC4I. Inside this count underscore 0 underscore I. So if you click on it, you will get this count out at the wave window. So similarly, I will do it for the XI timer 1. Interrupt I will add, and then inside this TC4 I will add this count out again, this 16-bit. Okay, so the signals are, I guess, are being added. Now let me run the simulation like for around 2.5 milliseconds, because I have tried it out and I have seen like after 2.5 milliseconds I was able to get all the interrupts. So let me write. Let's wait for some time to get all the interrupts. So it will take some amount of time. So please hold on. You can already see like this count out has been resetted to like 63. So let me quickly convert it to unsigned decimal for this one, and also for this GPIO. In the TCL console, you can see uh, like I have already got my 4 interrupts for the XI timer 0. So you can see like this 1, 2, 3, 4. So after this 4, it has stopped, and then I'm getting the first interrupt for the XI timer 1. So 3 more interrupts to get. Let's see. Okay, so we got the second one. Sorry. So we got our third one. We're about to get the fourth one, I guess. Okay, so we got only 3. So let me run it for another like 1 millisecond. So again we got the last one. So after that, I guess there won't be any interrupts coming. So, and also the counter values are stopped. Yes, you can see over here that my AXI timer 1 counter value has been resetted to 65535. So let it get complete. So from the TCL console you can see, like for the AXI timer 0 I am getting 4 interrupts, for the AXI timer 1 I am getting 4 interrupts. Now let us analyze. Okay, so let us analyze uh, from the waveform. So here I guess we got the 4 interrupts. So you can see over here, like this is 1, 2, 3, and then 4. So after this 4 interrupts, so you can see like the final where the counter has stopped is 104, and after that, since we have resetted it, so it is being reset to 63. This is my final value where the counter stopped, and then it is being reset to 63. For the count out, let us count the interrupt. So this is 1, 2, 3, 4. So after this 4, I am again getting, this is my reset value. So let me see like the last value of the over here. So you can see like 65084 is my, this the timer value where it has stopped, and after that it has been reset to 65535. Okay, so I guess it's working fine. And over here you can see like from the GPIO, you can see over here, zoom it. So you are getting 16. So 1 time, 2 time, 3 time, 4 time, and for the AXI timer 0, 1 time, 2 time, 3 time, 4 time. So it's working fine. So whatever is the requirement for the lab homework, we are getting it, and this is pretty much it. So there was nothing much to the lab. So we just need to include, so this dollar monitor thing was already explained by sir in the lab video. So we just need to include, let me go to the block diagram. So over here we just needed to include these two AXI timer IPs and the interrupts. We need to pass it by using this concat block, and one error is was like this microblaze local memory, it is the data one, it was overflowing with like some bytes, so we need to like increase its size like to 128k. You can use 64k as well, I guess it will work. So this was pretty much it, and in the SDK code we just need to define like twice for the two interrupt handlers for the two AXI timers, two reset values for the two timers, and that's it. It was very simple. I don't know why you guys couldn't submit. Anyways, so that's it from the video. Thank you.